Welcome back to the SOL-20 restoration. If you've been following the previous videos, we took it apart, checked the power supply, and found that one of the filter capacitors was done. So we replaced that and a couple more on the board. And the power supply seems to be working quite well. So I think we're ready to power it up. If you do remember, we found some cut traces on the circuit board down there. Processor Technologies released some ECNs, which are engineering change notices, and this is an early version. It has the early motherboard, or revision D, and these change notices, they would bring it up like revision D to E, E to F, F to G, and G to H, which I think is the last revision, and all the schematics that are available are revision H. And so what I thought I would do is pull this out and see if any of these changes had been made, if it had been at the factory brought up, or if this is just right a revision D straight up without any of the changes. The cut traces and the parts that were added to this power supply board do correspond to one of the changes to fix the crowbar circuit, which is over voltage protection. It's kind of like throwing a crowbar across the line. That's why they call it that. It basically just shorts it out so that it's not going to damage anything if the voltage gets too high. So I guess it was kicking in all the time, so it was changed. So whether this was changed by the owner or at the factory, I don't know if this was a kit version or a factory version. I don't know if there's a way to tell. If anybody knows, put it in the comments. So basically, I think we'll just go right at it, and I was going to take this out and look and see if there's any of the changes, but what we'll do is we'll wait and not add any kind of, if I start cutting traces and adding jumpers, it could bring a whole, like, mess something up. So let's just get it working 100% and then check the changes. So I think I'm still waiting for the period correct connectors to do this power supply modification, to bring the unregulated supply down into better voltage so that it's not putting stress on the S100 cards. So when we get these connectors, if we can get this whole thing going, we'll do a video of doing the power supply modification, and then we'll take the motherboard out and see if anything has been changed, or if we want to apply some of the ECNs. There's a few that seem like they're quite important, probably make the stability of the machine work a lot better. So we'll save that for later. And the other thing I found was this card here is a primitive, like, video card. It added some primitive graphics capabilities, but there's like no information I could find. I just found a little bit of information that it was available and you bought it as a kit and you built it. Take a couple chips off the board and move them to the top, and this plugs into where those chips came out, and then it adds a few things, but there's no schematic or any kind of information, software or drivers available. I can't find anything. So if anybody knows anything about this, you can also add that in there. I'm going to keep looking and see if I can find out information. So we might as well just go right for it and start applying some power to this thing and see where we're going to go. But the first thing I want to do is I just want to check see if there's any short circuits across any of the power rails before we apply the power. Like saying a capacitor has gone short or a chip is shorted, we can just check across from ground to like the 5 volt and see if there's any short. So that's ground to 5 volt, and there's resistance there. 12 volt, no short. Minus 12, no short. In between the 12s, there's resistance. 5 and 12, good. So there's no short circuits there. And we'll just check real quick up here on the unregulated supply. There's nothing plugged into it, so I can't see anything being shorted out unless there's some bad soldering going on here. But that would have probably happened a long time ago, so just quickly check these. Open. open. So there's no shorts there. So should be fairly safe to plug it in and power it up. What we will do is we will not put in this personality module, which has basically the ROM monitor, the operating system of the computer. Because I've done a lot of reading through the manuals and whatnot, and if we power it up without this module, what it's going to do is the computer's going to look to try to start booting from this, but it's not going to find it. So it's going to go through a cycle of just looking and looking, and it's going to fill the memory with 0 and 39 in hex. And it's going to also fill the video memory. So on the screen, if it's working, this will give us a rough idea of the system, if some of the systems are working in here. If the CPU is being able to write to memory or read to memory, and if the video memory is working, it should fill the screen with the 0 and hex 39. So what we'll see on the screen is like a 0 from the character ROM is like a square box, and 39 hex is ASCII 9. So we should see a box 9 filling the whole screen. So let's give that a shot. Plug this in. I might as well just plug this in too. Okay. The first power up of the SOL-20. Oh yeah, look at that. The whole screen is filled with 09 and it's flickering. That's a good sign too. That means that the CPU is running. So the whole screen is filled with 0s and 9s, which means that all the RAM from the video is working. And the CPU is running. Now, there's a little switch down here that has some jumpers that you use to do some settings. Switch 1 will hit the reset pin on the CPU. So if I flick this to on, it's going to halt the CPU and put it into a reset. So now we see the flickering is stopped, which means the thing is frozen. So it's like hitting the reset button. Turn it back on, and there it's flickering again. So the CPU is running. I'm just going to touch one of the pins with my oscilloscope real quick to see. Yeah, there's like an address. But this is a good sign. This is really good. That means the video section is working. It is reading and writing to RAM, to memory. So the CPU is working. So a lot of things are working. So let's power it off. Okay, now we'll put the personality module in, which is the software. So what should happen is now it's going to try to read from there and run the ROM monitor. So supposedly what we're going to see on the screen is a prompt and a cursor. And if that's the case, then it's basically, theoretically, it's running. So let's see what we got. We have a cursor, but we do not have a prompt. Let's throw the reset switch and see if we see anything move or change. No, nothing is changing. So that's running. So let's just take a look on the scope and see if the CPU is still working. And yes, it is. There's some stuff on the address bus, so that's working. So the CPU is still running, but we're not getting anything happening. So let's turn this off. So that's pretty good news. a lot of things are working, a lot of things are going right. But what it does tell us is a couple things. Well, is there a problem with these personality module? It has these old EPROMs that I don't have the capability to read. I have a universal programmer that does most chips, and I have another programmer that will do like the old 1702s, which are really hard to do, and 2708s and 2704s, but I don't have anything that can do these what are they, 5204s, I believe. 5204s. I don't have anything that can do that. So let's hope that it's not that, or else I'll have to do some research and see if I can come up with a way to modify one of my programmers or make something up. The other thing that could be is faulty RAM on the onboard RAM. We do know that the video RAM is working because it gave us a full screen of everything that we needed to see. But we don't know about these. My universal programmer can test some older SRAM, but it can't test these ones, unfortunately. Most like chips, TTL chips and stuff, they're ground and VCC are like VCC is on the top right and ground is on the bottom left. These RAM chips, VCC and ground, are both on the bottom right. For example, this is a 16 pin package. 4, yeah. So 9 and 10 are VCC and ground. So I could probably rig up an adapter for my programmer that would be able to test these. But there's another way. We have a whole pile of them on this board that came out. So obviously one of these has got to be good. We do know that all the video RAM is working. So we're just going to unconnect the personality module, slide it out a bit. So what we're going to do is we're going to pop out one of these video RAM chips and replace it with one of these chips and see if we still get it working. I have a chip puller somewhere, but I don't know where it is. Carefully drop it out here. So, if we stick this back in there, okay, let's not put it in backwards. That's a surefire way to screw things up. These old sockets don't seem the greatest either, so that could be giving us some problems. It might be an idea to reseat all these sockets. Okay, so let us see. Let's fire it up and see if we get the pattern. Okay, so that chip that we just put in there is good. Pop it out and turn it on and see what happens. Okay. Okay, so see there, it's something's up. So that chip is not in. It's like a squiggle 9. So some of the bits, one bit is off because we've taken a bit out. These are one bit chips. 1K by 1 bit. You need 8 chips to make 1K. Each chip does 1 bit. So we'll stick the personality module back in. Just turn it on for a quick sec. And all we have is the cursor. No prompt. So let's start testing these onboard chips. There's only 8 of them, so it's not going to take long. So if we test all these and no change, then we will know that we need to look somewhere else. It's possibly, it could be some address decoding chips, chip enable chips, some of the circuitry there. But this is probably the easiest things to do first. Check the RAM, check the EPROMs. We'll have to figure that out, how we can do that if we can. Then we can start digging into the schematics if we have to get that far, and then check the individual select chips and address decoding to see what's happening. So we'll fire this up. Same problem. So, next chip. That one out. And put this good one in. And here we go. Whoa, look at that. Look. We have a prompt and a cursor. So that is telling me that good things are happening. A prompt and a cursor is what we're supposed to be seeing, so I think it's up and running. So what we're going to do is we're going to plug the keyboard in and see what happens. Okay, I don't have a lot of faith that this keyboard is going to be working. From everything I've read, especially this being a very early computer, these keyboards, they're capacitive keyboards. There's a piece of foam and a little disc inside, and when you push down it changes the capacitance, and then that's what gets sensed, and then the keyboard works. And from what I read, the foam in these things just disintegrates into like dust, so nothing will happen. So the odds of this thing working is very low. So we're not going to be able to 100% know if this thing is actually, computer is going, if the keyboard isn't working. So, well, let's fire it up. There, we'll see what happens. Make sure that personality module is in. Turn it on. There's our cursor and prompt. So, let's see if we can get any keys. But it also could mean that the keyboard circuit is wrong, or a whole bunch of other things. But from what I understand, these keyboards are just like, need to be rebuilt no matter what. And especially this being a really old version, I don't see anything happening. None of the lights are working. So 2 things, the keyboard's either completely dead, nothing. We got nothing. Okay, so we don't know what's happening yet. Let's turn it off. But what they say is if you pull the keyboard apart, which is what we're going to do, and you touch the pad, what kind of screw is that? It's a flathead. Do I have a screwdriver? If you touch the pad with your finger, it will, your fingers will have a capacitance and it will change it. So I think what we're going to have to do is, I'm pretty sure, and it should be done anyway if you have one of these, is rebuild the keyboard. Now that's a whole different story, and that's going to be a whole video in on its own. So basically what we're going to do is we're going to see if we can get, I don't think I'm going to use my finger. I think I'm going to use a little capacitor to short it out and see if that's going to give us anything. So we're going to find out if we can get any kind of activity out of this keyboard. We're going to look inside first. And if that's the case, we're going to have to rebuild this thing. So I guess the next video is going to be rebuilding the keyboard, because without a working keyboard, we can't really test any further. So that's going to be a whole different thing, because I've read all sorts of things about how to rebuild these keyboards, and you can there's a company that sells the little foam pads, but they seem to be for other keyboards, and the results for the SOL-20 seem to be mixed. They maybe work, maybe they don't. Some people build their own pads. What they use is like mylar wrapping paper or mylar balloons. Another one I read was using anti-static bags. So I think we're going to have to do some experimenting. So let's get this apart and see if we get any activity up on the screen. There's a lot of screws holding this thing together. Okay, there's the keyboard. If you can see the lights are kind of shining on it. And here, you can see these little discs in there. Let's see if we can pop one out. Well, they seem to be all crushed in there. Oh yeah, there's the foam is just disintegrated. The little discs are probably not even getting. It's probably these little discs are probably not even. I wonder if we could reuse these little discs with a piece of foam that would get down. So it's probably not. They're not coming up. Okay, so let's put this somewhere safe. So, what they say you can do, you can touch these pads with your finger. Okay, how can we do this here? Maybe we won't short something out. Let's hold it down here. See that? Piece of paper. I am going to try to find something to put in between here. What's this? Piece of bubble wrap. Don't try this at home. This is probably a perfect way to short everything out. Alright, let us fire it up. We have our prompt and our cursor. Look at that. We have a letter. Another letter. I'm going to say it's the keyboard. I don't even know what half these pads are connected to. Okay, I'm using a little, I got a capacitor, using that to touch. That works a lot better. Okay, this keyboard looks like it's completely fried, but we're getting all kinds of things up on the screen. Maybe that's like an enter button, I guess. Look at that. Okay. So I think this thing is working to a certain degree. So I think what we're going to have to do is try to rebuild this keyboard. So I'm going to end the video there. If anybody has any experience rebuilding these keyboards or has success using different things, let me know in the comments. Otherwise, we're going to come back next time. We're going to do some experimenting with. I have a piece of Mylar right here. One of these anti-static bags. I wonder if I touch part of that, if that's going to do anything. I'm not doing anything. That kind of worked. Well, the anti-static bag isn't working. Maybe because of the way my finger is. Maybe you need the inside of the bag. The wrong kind of anti-static bag. I'm going to grab one of the little silver discs from here, from this keyboard, see if we can make one of those work. Get one out, crinkling it up. Oh yeah, the foam is completely disintegrated. That's working. I might be able to just reuse these discs. And just refoam them maybe. They just need to have something. They just need to be working, the foam. So maybe these discs look pretty good. They don't look like they're disintegrated. Seems to be working quite well. Okay, so we got some experimenting to do. So in the next video, it's going to be experimenting to rebuild the SOL-20 keyboard. Alright, thanks for watching. If you have any questions, put them in the comments. I'll try to answer them in the next video. But we're pretty, things are looking good. One thing I wouldn't mind checking before we go, which I didn't do and I should have done, check the voltage under load. See how that's looking. I'm not going to move my camera so it goes up to the multimeter. I'll just quickly check it under load. Just check if we have ripple back. We'll just do the 5 volt here because that's the big one. .1, that's what it was before, with 6 5-6 millivolts of ripple. So very stable still. The power supply is good. Still needs to be modified. So I think things are going along really well. Okay, that's it. I'll let you go. I'm gonna go do some more reading, figure out what we're gonna do for this keyboard experiment, and we'll see you on the next one. Have a good one.